So ladies and gentlemen, I welcome you back to our lesson of projectile motion. I hope that you looked at the notes and of course you tried out some numbers after watching the first video. This is the last video explaining some of the questions that we had in the classroom. So in case you didn't try them out, or in case you tried them out, please try to go through with me and we check our mistakes. I've left out some numbers for you as well. You'll try out number 1, number 2. The others have been explained. Remember to be part of us, of course. You can always pause, write down something, play again. So remember that. Don't just watch, pause, try out something, calculations. I've left out some calculations for you to complete such that we move together. So a quick review of what we had last time. We had about the equations of motion, we had about the projectile equations, and then some of the terms that we use in projectile motion. So to begin with, I'm going to begin with some of the equations that we use, and then we shall go to the questions in details. So let me first write down some equations that we shall be meeting. So we shall use basically the first 2 equations of linear motion. I've left out the third one. You can as well use it, but most commonly we shall be using the first equation of motion. Shall be using the second equation of motion, and then some of the projectile equations are velocity at any point during the motion. Shall be using that. We saw how it came out. The direction of the projectile at any time t is given in terms of the angles. We shall use this one to get the direction. The equation of trajectory, this one is very common. Equation of trajectory. And for me, I'll be using the cos in that equation. Otherwise, you can also use the the sec squared, the tan squared in the numerator. But for purposes of being simple, because I know there are those who don't do pure math. So the equation for the range shall be using this equation here. That will be the equation for the range. And you can simplify it and use this. And also note that for maximum range, this sine theta is equal to 1. So for maximum range R max, it is always given as u squared out of g. So those are the equations that we're going to be using in this tutorial. You can always take a snapshot, you can always pause and write anything. So number 1, I've left that one for you to complete. And number 2 has also been left for you to complete. Number 3, it reads like this. A blade is fired at an angle of 45 degrees to the horizontal from a point A. The blade passes through a point B above the horizontal through A. The horizontal should be through A, with B having coordinates of 600 and 225 meters. In other words, this is like the x value, this is the y value, because this is a coordinate. Calculate the speed of projection, and also calculate the speed and angle with which the blade makes with the horizontal as it passes through point B. So let us try out this question together. Let's first have a simple sketch. So with this sketch of ours, we see that the x, or the horizontal distance covered, is 600 meters, and then the vertical distance covered is 225 meters. That is at point B, and we've been given the angle of projection as 45 degrees, but we have not been given the initial velocity u, and that is our first question, Roman 1. So from this question, we see that we've been given the x and the y values, and also the angle of projection, which means that we can use the equation of trajectory. So using that equation of trajectory, we know that we've been given the y, we have the x, we have the angle. Substituting our values into that equation will give us our initial velocity u as 97.04 meters per second. So after having got our value of the initial velocity u, let's now turn to the second question, which is find the speed and the angle with which the blade makes with the horizontal as it passes through the point B. So for this part here, Roman 2, assuming that our body is at this point B here, and that velocity at that point is having the horizontal component, which you can call Vx. I'm calling it the final velocity V at that point. The initial was U, and then the velocity vertically is Vy, and our resultant velocity V will be pointing in that direction, and the angle at that point will be that angle theta. So from the first equation of motion, V is equal to U plus AT. Horizontally, we're going to find the velocity at that point Vx at point B. So substituting to the first equation of motion, we shall say that Vx is equal to U cos of theta. And remember that A is equal to the G, which is equal to 0 horizontally, of course. So substituting into that, we shall get our horizontal component of the velocity at point B as 68.59 meters per second. Then the vertical component, still from the first equation of motion, we are going to substitute for the A and replace it with negative G. So Vy is equal to U sine theta minus Gt, but at this point here we don't have the time taken for the body to move from point A to point B. So what we're going to do, we're going to use the equation of motion, and we get the time taken. So horizontally, we know that the S is the X. Of course, the A is equal to 0. That is horizontal. So substituting to this, we have our X as 600, our U as 97, the angle theta is 45, and then the T. So the T is the only remaining unknown, which gives us the time taken to move from point A to point B is 8.75 seconds. We have used the horizontal direction because we have the horizontal distance covered, the time taken, and then the angle. Another person may use the vertical direction. We have the Y as 225. We have the A, this time around, if you substitute into the second equation of motion, the A is the G, which is equal to negative 9.81. The body was going upward, so that's why we have that negative there. And then we have the angle like that. So substituting into that equation, our Y is 225, our U is 97, our theta is 45. So we shall end up with a quadratic equation whereby the T is the value that, the unknown that we have to look for. So the quadratic equation, and the quadratic equation normally gives us two values. So whatever value that you get here, remember that time is never a negative. So choose the positive answer from there, which will be 8.75. Try that out. So after having got our time, we can now get our vertical component of the velocity at point B, as when we substitute into, we shall get our vertical component of the velocity as negative 17.25 meters per second squared. So that is the vertical component of the velocity at point B. Once you've got that, remember we said at the beginning that the velocity at any point, in projectile motion is given by this equation here. So the horizontal component is Vx, the vertical component is Vy at that point B. Substituting into that, we shall get our velocity at that point B as 70.7 meters per second. And the direction of the body at that point is got from, remember direction is the angle. So the direction is got from tan inverse of vertical component divided by the horizontal component of the velocities at point B. So substituting into those with the negative on the Vy, we shall get the answer as negative 14.1 degrees. And that is the answer that was given in the question. So downwards. Yeah. So that is number 3. Alright, so let's look at number 4 after looking at number 3. Number 4 says that a projectile a projectile fired at an angle of 30 degrees to the vertical. Oh, this is the vertical now. A projectile fired at 30 degrees to the vertical strikes a building 30 meters away at a point 15 meters above the point of projection. Find the speed of projection and the velocity of the projectile when it strikes the building, when it strikes the wall. So that is number 4. Let's look at its sketch. So when we come up with the sketch of this information here, the question said that a body is projected at an angle of 30 degrees to the vertical. This is the vertical here. So to the vertical, and 30 meters away. So we have our 30 meters away as the horizontal distance at a point 15 meters above the ground. And of course we don't have the angle of projection. The first thing to do is to get that angle of projection, and we shall simply get that from simply saying 90 minus 30 gives us 60 degrees. So our angle theta is equal to 60 degrees. So once we've got that, then they want us to get the speed of projection, just like we did in number 3. You can use the equation of trajectory, and then you find your speed of projection here. Then, still using the first equation of motion and this equation for velocity at any point, you can find the velocity at any point using that equation, and of course the direction also using that, just like we've done in number 3. So go back to number 3, look at it again, come and try to do this number 5. Number 5 says that a shot is fired from the top of a cliff 250 meters high with a velocity of 650 meters per second at an angle of elevation 30 degrees. Find the distance from the point where the shot strikes the water to the bottom of the cliff. So in this question, if I'm to look at what we've been given, I've been given the vertical distance covered 250 meters high. We've been given the initial velocity of projection as 650 meters per second, and then the angle of projection at 30 degrees. So they want us to get the distance, the horizontal distance from the point of projection to where the shot strikes the water. Let's begin by drawing a simple sketch for this information as well. So we have that sketch there. We have been given the vertical displacement. We've been given the angle of projection and then the speed of projection. So they want us to get the horizontal distance covered by the projectile. So if you look at the equations to use, we can see that we can use the equation of trajectory as well. So the equation of trajectory is given as y is equal to x tan theta minus gx squared 2 into u cos theta square there. Like that is the equation of trajectory. Of course, you can replace this cos squared theta, bring it to the numerator and place there the sec squared. You can place there the tan squared and so on. But this is somehow more easier for even those who don't do mathematics. So, from this I have substituted the y as a negative in that equation there. Why have I done so? If you look at a number line, if this is our number line, this is 0, this is 1. So going upwards, we have positives. And then going downwards, shall be having negative values. So I've taken this one to be a negative because when you look at it, this initial horizontal level of projection, this one here, And since we're assuming that the body, since we're saying that the body is going upwards, it means that considering the initial direction of motion, where the g is a negative, already that is reflected in the equation, and it means that whatever is going upward is a positive. It means anything going downwards is a negative. So this displacement is measured going downwards, and that's why we have a negative. So substituting into the equation of trajectory, we shall end up with a quadratic equation where the unknown is the x, and solving that equation will give us two values of x, a negative and a positive. But of course the distance cannot be negative as we've seen in that equation there. Therefore our displacement is positive 37,730 meters. So that is our displacement horizontally as seen in the question. If you don't want to use the equation of trajectory, you can begin from first principles using the second equation of motion. So if you are to use the second equation of motion, the alternative method, using the horizontal direction, our equation, like this, we have the u, we have the theta, but we don't have the time t. So calling that on our equation 1, let's first look for the time taken for the motion of that body there. So using the second equation of motion, the s or the y is negative, distance as I've explained above there. The u is given, so that will be u sine theta. The a is the negative g, which is 9.81. So still we shall end up with a quadratic equation in terms of the time t, and solving that gives us two values of time, whereby one is a negative and time cannot be a negative. So which means that our time will be got as 67 seconds. Try this one out. Get a calculator, try it out. So substituting our time into the first equation, we shall get our horizontal displacement covered by the projectile as 37727 meters. There's a slight difference in the answer, but we can take it to be like that. So that is our number 5. Number 6. Plane is moving at 1,500 meters per second. There was a mistake there. Drops a bomb when it is at a height of 0.5 kilometers. Remember that the units must be similar. So you change that one to 500 meters above the ground. With reason, state whether the bomb falls to a point on the ground below the point of release or not. Sure working. So that is number 6. When we look at this number 6 here, it is almost the same as number 7. Number 7 says that a box is released from, the other one was a bomb. So this one is a box is released from a plane moving horizontally at a steady speed of 50 meters per second. 50 meters per second at an altitude of 300 meters from the level ground at point X. Remember the other one was 0.5 kilometers. So I have to change that one to meters. Since the speed is in meters per second, even the distance or the displacement must be in meters. So at an altitude of 300 meters from the level ground at point X, find the time taken for the box to hit the ground, the speed of impact with the ground, the horizontal distance covered by the box from the point of release just before impact. So when you compare these two questions here, these two questions look alike. Of course, the body will not hit the exact point just below. I'm going to work out number 7. You'll work out number 6. The answer is there. So number 7, let me begin by drawing a sketch for this question here. A simple sketch. Always try to draw a sketch. So that is our sketch. When you look at that sketch there, they're saying that a box is released from a plane moving horizontally. So from that statement there, what do you think is the meaning of that word horizontally? So it means that the angle of projection is 0. In other words, if this is the horizontal, the angles of projection are always measured from the horizontal. Remember the definition. Angle of projection is the angle between the horizontal and the initial direction of projection. So if the angle is measured from the horizontal going upwards, that will be positive. If it is going downwards, it will be a negative. So according to the question, the body was moving horizontally, which means therefore that our angle of projection is 0. So our theta is equal to 0 degrees. So given the initial velocity, given the vertical distance covered, of course the body starts from this point here. If the body was originally in motion, it will continue in motion in a straight line according to Newton's first law of motion. But because of gravity, that gravitational pull, the body finds itself moving downwards along that trajectory there. So which means that therefore that the body cannot, if the body was already moving in air, it cannot fall exactly downwards to that point. That was in question number 6. So that has been explained. So therefore, the body covers a horizontal distance x, and in the question we're supposed to find that horizontal displacement x. So the first question says that find the time taken. Of course, we say that before you do anything, first look at what has been given to you in terms of the values, look at the equations of motion, look at the equations used in trajectory motion, and then try to find out the most suitable one. So in this question, part 1, they're saying that find the time taken. We cannot use the first equation of motion to find the time taken because we don't have the final velocity. But if you look at the second equation of motion, we can use that to find the time taken. Let's try it out together. So from the second equation of motion, s is equal to ut plus a half at squared. Vertically, I'm assuming that the body was going upwards. That's why my g is going to be a negative. So taking into consideration the initial direction, if you assume that the initial direction is going upwards, I will assume that my g is going to be equal to a negative, which means therefore that our vertical displacement covered was going downwards, which means that our s will be equal to a negative. So that's why I have negative 300 there. So therefore, when I substitute into that, our angle theta is 0. So sine 0 is 0, which means that we shall end up with negative 300 is equal to negative 9.81 divided by 2 t squared. So substituting, solving that gives us our time taken as 7.82 seconds. If you assume that the velocity, the initial direction is going to be downwards, then use a positive here, also use a positive there. So that is Roman 1. So after having got the time taken as 7.82 seconds, let's now go to Roman 2. Find the speed of impact with the ground. In other words, find the speed at this point here. Of course, when they say that find the speed of the velocity, you also find the direction. So that point there, it is having both the horizontal and then the vertical components, as I've seen before. So going back to the first equation of motion, from the first equation of motion, we can see that horizontally, the a is 0, which means therefore that our Vx is equal to u cos of theta. And substituting our velocity 50, the angle 0, we get our horizontal component of the velocity as 50 meters per second. For the vertical component of velocity, still using the first equation of motion, Vy is equal to 50 sine 0. Sine 0 is 0. So which means therefore that our vertical component of the velocity, when you substitute into that, we shall get negative 76.71 meters per second. And of course, remember the velocity at any point is given by the square root of the Vx squared Vy squared. So substituting into that, we shall get our velocity of impact with the ground as 91.57 meters per second. And in the direction given in terms of the angle is always given as the tan inverse of Vy over Vx. Don't forget the negative, implying therefore that our direction is negative 56.9 degrees. This negative here will say that it means that the body is moving downwards. Alright, so then find the horizontal distance covered by the projectile. So from the second equation of motion, horizontally, of course, we say that this A here is equal to 0. So substituting into that, we shall get our x equals to 50 cos of 0 times the time taken, and therefore our answer is 391 meters horizontally. In case you don't want to use that, you can as well use the equation of trajectory. Y is equal to x tan theta minus gx squared out of 2 into u cos of theta square everything. So we'll find your equation, the horizontal displacement covered as 391 meters. So that is number 7. Don't forget to try out number 6. Number 6. The same working. Alright, so after having done it that, we can then go to the last number in the question, which is number 8. Lastly, number 8. Number 8 says that a hunter running at a constant speed of 10 meters per second throws a spear at an angle of elevation of 30 degrees to the horizontal with a speed of 25 meters per second. We're having two velocities here, or two speeds. 10 meters per second for the hunter, and then given that the spear was held at the shoulder level 1.8 meters high, and that he was aiming to strike a sleeping animal 0.2 meters high. Calculate the time taken for the spear to hit the target from the time of release. And then 2, it says that the horizontal distance covered by the spear from the point of release to the target. And then finally, Roman 3, the velocity and direction with which the spear hit the target. That is our last question. And please always remember this. Remember to be part of us. Share. So in this question here, it is a combination of both projectile motion and then the resultant of velocities of vectors. So we're going to borrow an idea from resultant of vectors, and we apply it here as well. Let me first draw a sketch of this. So according to that sketch there, we are having the velocity of the hunter as 10 meters per second. Remember, it is horizontal. We're having the velocity of the spear 25 meters per second at an angle of elevation 30 degrees measured from the horizontal, of course. And then we've been given that the spear was released at a height of 1.8 meters to hit a sleeping animal which was 0.2 meters high. So the question says that find the time taken, find the horizontal distance, and then find the final velocity of the spear. So with these two velocities here, what do we do? What do we do with these two velocities here? So what we shall do, we shall first of all get the resultant of these two velocities, and that resultant is what we shall be using as the initial velocity of projection. There are very many ways of doing this. You can complete a parallelogram of vectors. This one is going this way horizontal, this one is going this way. So this one is going upwards, this is going upwards. Where they meet, we have our resultant velocity u, which we need. And of course the angle of projection will be that angle theta. We need to calculate for that one as well. So you can use any method. If I'm to extract out this, I'll end up with this diagram here. This is u. this was 25, this was 10, and this is 30 degrees. If this one is 30, then it means that this one here will be 150 degrees. So using any method, you can use sine rule, you can use cosine rule, you can use any method. So let me use the cosine rule to get the velocity u, and then I'll use the sine rule to get the angle of projection theta. If I'm to use, remember the cosine rule is given as a squared is equal to b squared plus c squared minus 2bc cos of theta. So if I'm to look at that, this one is going to be my a. I can call this will be my b, this would be my c, like that. So I'll say that u squared is equal to b squared. I've called my b to be 25. 25 squared plus 10 squared minus 2 times 25 times 10 cos of 150. If I'm to solve this, I'll get my u to be 34 meters per second. Alright, so that is my u. Then let me try to get the angle theta. So using the sine rule, so after getting our initial velocity of projection as 34 meters per second, we can get the angle of projection using the sine rule. Remember, if this is our triangle, if this one here is our triangle, this is the angle theta, we use this side b. If this is the angle 150, we shall use this velocity u. That is the sine rule. So the sine rule, after doing that, we find that when we substitute into our sine rule, we shall find that our angle of projection is 21.57 degrees above the horizontal. So coming up with our diagram, the final diagram, it will look like this. So the sphere was around 1.8 meters, the animal was 0.2 meters. So in subtract that, it means that the sphere has traveled through a distance of 1.6 meters vertically. So using our equation of trajectory, y is equal to tan x tan theta minus dx out of 2 into u cos theta, everything squared. When you substitute our value of y, remember it is going downwards. I explained that. So we use negative 1.6. The x is unknown, is what we are looking for. The theta is 21.57. The x is unknown. So substituting into that equation there and solving it, we get two values of x, one being a negative, but remember, according to our diagram, the x cannot be a negative. So which means that therefore that our horizontal displacement covered by the sphere or the projectile is 84.84 meters horizontally. So using that very displacement and substituting it in the second equation of motion, we shall get that our x is equal to u cos theta times t. Remember, the a is equal to 0. The acceleration of gravity a, or the g, is equal to 0. So substituting into that, we shall get our time for the sphere as 2.67 seconds. And then finally, Roman 3, getting the velocity of impact. Using the first equation of motion, horizontally the a is 0. So substituting into u is velocity horizontally is equal to u cos of theta. So substituting into that, we shall get our horizontal component as 31.64. Vertically, it will be u sin theta minus gt. So substituting into that, we shall get our vertical component of the velocity as negative 13.69 meters per second. Finally, getting our velocity, it will be the square root of Vx squared plus Vy squared. Substituting, we shall get our velocity of impact as 34.6 meters per second. And of course, the direction of the sphere, direction of impact will be negative 23, meaning that the sphere was going downwards. And therefore it hit the target at that angle there. So negative 23.41 degrees. So that is our work. So remember to like and share, and of course tell everyone to join. Have a nice time.